Good evening, students. Today we are going to look into the tips required for competitive exams. The topics we are going to discuss are highlighted, so we will go through it one by one. The first thing, for ellipse, we have seen the basic forms of ellipse. And the first point we would like to discuss is the parametric form. So when we say parametric form, the x and y are separately defined. So the parametric form is written this way: x is a times cos theta and y is b times sin theta. Well, sometimes it is found that students lack clarity of what is this theta. It is easy to say x is a cos theta, y is b sin theta. So any point on the ellipse, right on the ellipse, can be represented in parametric form as a cos theta and ordinate b sin theta respectively, and I am joining the line segment from O to P, and we already know the segment OP stands for, the distance from center of the point. Okay, and assuming x dash to be the major axis, I can say angle POX is what we refer by the term theta, the angle theta. The angle theta has its own name also. It is called the eccentric angle of the point P. Eccentric angle of point P, that is angle POX. Done. So this way you can represent the parametric format. It helps you in more than one way. See, in terms of parameter, we can define slowly. I am moving into the concept of tangent normal. The slope of tangent at that point P, slope of tangent at the point P can also be given in terms of the parameter theta, that is the eccentric angle theta. So slope of tangent, let me represent by means of this subscript m subscript t. Okay, so it is negative b divided by a times tan theta, a tan theta appearing in denominator. So that is slope of tangent. Well, how do we derive this? Why should we simply memorize minus b by a tan theta? And what if you forget minus b by a tan theta? Well, we already know the standard equation of ellipse. So any student can derive dy by dx. So once you derive dy by dx, substitute a cos theta and b sin theta. This is one way you can arrive at slope of tangent. Another way you can derive the slope is, we already know how to prepare equation of t by replacing x square with x1. So x times a cos theta by a square y times b sin theta by b square gives 1. So x by a cos theta plus y by b sin theta equal to 1. From that also we will be in a position to write the slope of tangent in terms of parameter. Once we come to the understanding of slope of tangent, we are able to write the slope of normal at point P also. So let me denote it by slope m subscript n for normal. So we know it is negative reciprocal. So I'm sorry, it is a by b times of tan theta. So tan theta goes to numerator, it becomes a by b tan theta. So slope of tangent and slope of normal is easily done. It also helps you to discover the point of contact easily. And the following concept is condition for tangency. So when we talk about condition of tangency, let me take the straight line y equal to mx plus c. So c square is a square m square plus b square. A square m square plus b square gives condition for tangency. In other words, I can say y minus mx the whole square is a squared m squared plus b square. Y minus mx the whole square is a square m square plus b square. Well, this will help us to produce the equation of tangent whenever the tangent to ellipse or hyperbola. Hyperbola we will write a different condition. Whenever the tangent is prepared from a point outside the ellipse. So let me just the point outside the ellipse. Okay. So if you want, I can give a simple example. X square by 16 plus y square by 9 equal to 1. Let that be the equation of ellipse. So we know the vertices are 4 comma 0 minus 4 comma 0. Let me select minus 5 comma 0 to be a point from where I wish to draw tangent to the ellipse. And as you can see, you can draw a pair of such tangents. Two such tangents are possible from minus 5 comma 0. So let me say the point I am using is minus 5 comma 0. We would like to derive the equation for the pair of tangents. Equation for pair of tangents. And how am I going to do this? So I assume let y equal to mx plus c be the line which is tangent. And minus 5 comma 0 satisfies. So y is 0 and minus 5m plus c, okay, and therefore c square is negative 5m squared, that gives 25 times m squared. But we are going to now apply the condition, that is c squared, the criterion c squared equal to a square m square plus b square. So applying the condition, what we get, a square in our case 16 m square plus 9. Upon simplification, I get 9m squared is 9, which implies there are two slopes available. m1, m2, and the values are positive 1 and negative 1 because m squared happens to be 1. Because m square happens to be 1. So I get one slope positive 1, I get another slope negative 1. So I can easily prepare the equation of two tangents as the two tangents are y equal to positive 1x plus 5 and negative x sorry negative x negative 5. So I am able to write the equations of both the tangents from this idea of c squared equal to a square m square plus b square. So it always gives you the equation of both the tangents, not only one. Done. What about the next concept, the chord of contact? So when we come to chord of contact, so first let us discuss the idea, when will we get a chord of contact? Ellipse, and again consider a point outside. Whenever in a question you are given equation of ellipse and a point, it is necessary for the student to judge and find out whether the point lies inside or on the ellipse or outside. So we know the criterion S1. So S1 less than 0, equal to 0, greater than 0. These are three statements, three criteria by which you can judge. Less than 0. So that means the point lies inside. S1 gives 0, implies the point is right on the ellipse. S1 greater than 0 implies the point lies outside. So if we wish to prepare chord of contact from a point, essential criterion is S1 greater than 0 for that point with reference to the equation of ellipse S. And it is understood that a pair of tangents is drawn and a straight line segment is drawn. So that becomes chord, but they join the points of contact of the tangents with the ellipse. And the equation of COC, very simple. So by preparing T equation, we can get COC. So T is equal to 0, sufficient. So what do we mean by T equivalent to 0? T already implies the replacing procedure. So I mean replacing, I am just revising x1, y squared replaced with y, y1, etc. Okay, x replaced with x plus x1 by 2, y replaced with y plus y1 by 2. Just in case there is a xy term, it is replaced with x1y plus xy1 whole divided by 2. So that makes the concept of COC simple. Then we are here to understand the concept of two kinds of circles. The first one being the auxiliary circle. Auxiliary circle. Once again, it is very much dependent on the geometry. So I produce the ellipse. Let me focus on one particular tangent to the ellipse. say located at point P, and let me call PT is the tangent. We all know there are two foci, I call F1, F2, located at C, 0, negative C, 0. And we draw perpendiculars from each focus upon the tangent. Let me draw the perpendicular from focus upon the tangent. I get what we call foot. So let me say foot 1, foot 2, maybe call them as M and N. And similar feet of perpendicular, similarly, I can produce on any tangent. Prepare foot of perpendicular, prepare foot of perpendicular also. Okay, so let me call this point as R and S. So like this we can prepare several feet of perpendiculars. So feet of perpendiculars from foci upon any tangent. Feet of perpendiculars we prepare. Okay, what are we going to do with these feet? Join all the feet wherever we get the feet. We call the trajectory or the locus of all the feet together and prepare the curve. Let me make it more clear. So by preparing the curve joining all the feet of such perpendiculars, we end up in a circle, okay, and that is called the auxiliary circle. So we end up in a circle, and as you can see, it has radius semi-major axis, that is the radius. And semi-major axis, we all know it is A. So the equation of auxiliary circle becomes x squared plus y squared equal to A squared. So this is the concept of auxiliary circle. So any tangent, okay, and upon any tangent, once we produce two perpendiculars from the pair of foci, we get the pair of feet. And infinite tangents can be drawn, and similarly infinite feet of perpendiculars are arrived at, and by joining all the feet we get a continuous closed curve which forms a circle, and it has the radius equal to semi-major axis. Hence equation is x squared plus y squared equal to A square. The other concept I would like to deal today is director circle for the same curve ellipse. Director circle. Once again, we will highlight the ellipse. And consider any one tangent and consider its, let us say, a perpendicular pair. Consider a perpendicular pair. Ideally, what I can do, I can draw tangent at the end of minor axis, tangent at the end of major axis. Definitely they are mutually perpendicular. Okay, fine. So similarly I can produce mutually perpendicular tangents which are again infinite. and the points of intersection of those mutually perpendicular tangents. Points of intersection of those mutually perpendicular tangents, they are joined, and I get another circle in this case. In this case, it is not coming in contact with any point on ellipse. It forms still a circle. It still forms a circle, but away from the ellipse. So this circle has radius square root of a square plus b square. As you can see, because very simple to arrive at that radius, you can see the radius is the hypotenuse. I have the base here, semi major axis, and the height semi minor axis. So what I am able to do is find the radius, prepare equation of director circle, x square plus y square equal to a square plus b square. So this is what is the concept of mutually perpendicular tangents. Well, this can be seen in two ways. One is the straightforward method of the locus of mutually perpendicular tangents. The points, meeting points are joined, they form director circle. On the converse, what we say, from any point on a director circle, if you happen to draw the pair of tangents, they become mutually perpendicular. So this helps you to tick the right choice whenever MCQ is given. A point is given, an ellipse is given, and the question is find angle between pair of tangents. So immediately a student is supposed to verify whether that point lies on director circle. If the point happens to be part of director circle, immediately you can take the answer pi by 2 because they are mutually perpendicular. Well, the next concept is the concept of diameter. Well, diameter is very easy for a circle. Radius and diameter you understand by default in the case of circle, but it is not so in the case of ellipse. So then in ellipse, what we understand as diameter, given, let us say, y equal to mx plus a random value c, keeping slope m constant, let us say a system of straight lines which can effectively become chords, and keeping m constant makes a system of parallel chords. Okay, so you are able to arrive at, I have just drawn a finite set of parallel chords, whereas infinite sets is possible. So because C is real. Now what we wish to do is take up the midpoint of all the chords, midpoint of chord, midpoint, 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 and we wish to join all the midpoints. And as you can see, it passes through the center. So the very first preliminary understanding is diameter essentially passes through the center of ellipse. It passes through the center of ellipse, and if origin is the center, as the basic equation x square by a square plus y square by b square equal to 1 goes, so it is a line passing through origin. Diameter is a line passing through origin. So what is the equation of diameter? If slope m is already given and knowing the equation of ellipse, thereby knowing the values of a square and b square from equation of the ellipse, you can write it as negative b square x by a square times the slope m, a square times the slope m. Well, this is the equation of diameter. Provide the m here indicates the slope of the system of parallel chords that we drew. Then a small addition to it, whenever there is a diameter, there is always a conjugate diameter. Conjugate diameter. A pair of conjugate diameters will have the product of their slope, which is product m1, m2 is negative b square by a square. So this is the essential criterion when it comes to a conjugate diameter. Well, the question can be anything like finding equation of diameter or given a diameter, what is the conjugate of that diameter. Fine. So as much as like we were able to highlight all these tips for ellipse, we can similarly highlight all these tips for hyperbola also. By making suitable alterations or additions, let us discuss the hyperbola. Equation, the basic equation we all know, x square by a square minus y square by b square equal to 1. A happens to be semi-transverse axis, b happens to be semi-conjugate axis. The parametric form, we will go through it quickly. The parametric form, x happens to be a times sec theta and y happens to be b times of tan theta, which means any point on hyperbola can be represented in terms of the angle theta, and we need not discuss what is the angle theta separately. We know it is the eccentric angle. The concept remains the same. Maybe the diagram is slightly different. Let me draw the diagram of hyperbola. Okay, consider any point. So join the center with that point. Eccentric angle is called theta, and it is that theta what we use to make a sec theta comma b tan theta. And proceeding to condition of tangency, y equal to mx plus c becomes a tangent for the hyperbola if in case c squared equal to a squared m squared negative of b squared. As much as we saw the case, the condition for ellipse as a square m square plus b square. Okay, I think right from the basic theory when we were discussing hyperbola, we were giving a simple technique of changing the sign of b square term alone, okay, to arrive at suitable expression for hyperbola. So that works here also. By changing plus to negative b square, we get the equation, the condition for tangency. What about the slope of tangent in terms of parameter theta? In terms of parameter theta, slope of tangent, m subscript t. So b divided by a times of sin theta is the this is the answer for the slope of tangent. How is this arrived? I told you there are already two different ways. One is you prepare tangent equation by the replacing technique x square xx1 y squared yy1 and thereby minus x coefficient by y coefficient will give you slope of tangent. Or in other words, you can also do differentiation and arrive at this expression b by a sin theta. So once we have the slope of tangent, we can also arrive at slope of normal, which is negative reciprocal of b by a sin theta. So which is minus a sin theta over b. So minus a sin theta over b. So that becomes the equation, the slope of normal in terms of parameter. And the next comes chord of contact. The chord of contact, there is no difference between whether it is ellipse or hyperbola. But one thing, here I told you how to check whether the point lies outside of the curve. There is a drastic change here. P lies outside hyperbola if S1 is less than 0, not greater than 0. In the case of ellipse, we saw the point lies outside only when it is S1 greater than 0. In case of hyperbola, it lies outside when S1 is less than 0. So this is one change students have to make note. After verifying the point lies outside the hyperbola, you can prepare chord of contact by simply t equal to 0. And the next thing, the concept of auxiliary circle. Auxiliary circle, the meaning of auxiliary circle, the definition of auxiliary circle doesn't change. So the feet of perpendiculars from foci upon any tangent. You can draw any tangent, consider any tangent. There is focus 1, draw foot of perpendicular. There is another focus, draw foot of perpendicular. And similarly, you join all feet of perpendicular. We arrive at a closed curve, which is again a circle. Okay, so it is auxiliary circle, which is x square plus y squared equal to a squared, which happens to be the measurement of semi-transverse axis in the case of hyperbola. And quickly going to the director circle, that is the point of the locus of points of intersection of mutually perpendicular tangents. So x square plus y squared is a squared minus b squared. So this is the, again there is a change. The sign of b squared has to be changed from positive to negative. So equation of director circle we can arrive at. Similarly, diameter concept also, equation of diameter, the meaning does not change. You prepare system of parallel chords, okay, and cutting the hyperbola and take their middle points and midpoints, you keep joining and it passes through, still passes through the center of hyperbola only. And equation is y is equal to sine of b squared to be changed. Here it is already negative, so you make it positive b square x by a square times m. So that is the equation of diameter. And conjugate diameters will have the product, their product m1 m2 as b square by a square. Well, students, so this way we are able to correlate many very important clues from which you can answer multiple questions for JEE main MCQs. So with this I conclude the necessary tips and tricks for JEE MCQ, and in the next session I will meet you with a bank of MCQ questions taken from previous exams and mock tests. Thank you.